All right, good morning. So welcome to day 2. We're going to be talking about power of powers. So I'm going to write that in here. Same objective. We're going to be simplifying expressions. But today, the multiplication property of exponent that we're going to be focused on is power of a power. Okay. And so let me go ahead, scroll down. Yesterday, we talked about product of powers. Today, let's go ahead and talk about what power of power is. And I'm going to write it right here. Power of a power. So when we're kind of introducing parentheses here, we got like a to the power of m, and then you take that and you put that to the power of n, right? And so basically the rule states that we're just going to multiply our exponents. And so I'll show you why. You take a really easy example, like x to the third, and then we're going to take it and put it to the power of 2, right? So what this means, and I'm going to be focused on that 2 right there, is that I just take whatever's inside and I write it 2 times. And so that's going to be x to the third and then x to the third, right? And so what just now we've gotten, basically, we just have this, which looks a lot like what we did yesterday. Each exponent has its own base, and we just add, and we get x to the power of 6. Are you with me? If you're not quite with me, you're like, wait, I don't remember yesterday. Okay, x to the third would just look like this, x times x times x, right? And then here I got another x to the third, so that's x times x times x. And when we count it, that's 1, 2, 3, 4, 5, 6, so x to the 6. So all they're saying was, instead of doing all of that, we could have just said this, x to the power of 3 times 2. And we would always end up with x to the 6th power. Questions? Okay. So let's get into example number 3 here. Okay. And I think what I want to do is I really want to address this part right here. Let me see if it'll make it look pretty. No, it got a little too much. That's okay. I really want to address like the outer bracket with the outer exponent, right? So that's to the power of 2. So what that's saying is that we're going to do it 2 times. And you know, if you forget the rules, you can always write it out like way big, right? So I got something 2 times. All right, and what I have it in there, I'm going to just whatever's inside there, right? That's going to be 2 to the power of 3. And then put that to the power of 3, right? So I kind of made that parenthesis too big, but you get the idea. And then 2 to the power of 3. And then that to the 3rd power, right? So I'm just multiplying it by 2 times. So this, if I clean it up, looks a little bit like this. 3 to the power of 3 times 3 times 2 to the power of 3 times 3. Do y'all agree that that's the same thing? Yes. Okay. Now that I have that, I'm really going to focus on this part right here. Okay, the little brackets to the 3rd power, right? So I'm going to take whatever's inside and I'm going to do it 3 times. So that's going to be 2 to the 3rd power times 2 to the 3rd power times 2 to the 3rd power, right? That's the first one. And then the second one, I'm going to take this and do it 3 times. And so that's going to be 2 to the 3rd power times 2 to the 3rd power times 2 to the 3rd power. And this is where we had yesterday, right? Where we just, every exponent has its own base. And so we just added up 3 plus 3 plus 3 plus another 3 and another 3 and another 3. So 3 of the 3's coming from right here, right? Yes, ma'am. And then right here, the other 3, you got it right there. So that adds up. 3 plus 3 plus 3 is 9, and another 9, and you end up with 18. Can we talk about a smarter, faster way that I should have done it right from the beginning, because I got a feeling that's what your question's about?
Well, I don't really know if this is faster or shorter, but I'm doing it a different way than both of these.
Okay. Yeah, hold on one second. Let me talk about your way. Like, anybody else think of this the faster, easier way than all of that every single time? How can I get 18? Ideas? Okay. What if I just took this and I said 2 to the power of 3 times 3 times 2? See, because all of them are right next to the parentheses, right? All of them multiply. So 3 times 3 times 2, that's 9 times 2, that's 18. Same thing, right?
That's
Now,
what I was doing.
That's what you were doing? That was your smarter way? Yeah, I
so
told you.
I think I consider myself a visual learner. I
Uh-huh.
don't like it when everything's all laid out like this.
Right, right, right.
So I would just translate this into like the 3x,
Mhm.
the x, and the x2 to the power of 3, power of 2. As it 3 times 3 in parentheses, so times 2, then x, 2 times 3 times 2.
All right, whatever works better. I mean, once you kind of understand, it's great. If you forget the rules, you can always spread it out and just make sure. Now, keep in mind, it may not be like this on the test. You might actually see, especially when it's a constant, you're probably you're gonna take it to your calculator too. And just to kind of show you, you have a caret right here. That button right there, it's called a caret, will let you enter any kind of exponent you want. You can put 18. And so this is equivalent to the answer of 262,144. Okay, and that's how you get that. All right, ladies and gentlemen, let's go ahead and let's discuss this one, example 4. Go ahead and type in, if you know, what is the formula for the volume of a cube? Okay, volume of a cube. And that's my best attempt at a cube. Okay. Okay. So base times width times height for like a general, any type of rectangular prism, right? But what's unique about a cube, and my drawing probably does not help the situation, but all sides are equal, right? So my favorite one, and Rebecca was almost there, good, is that you can take the side, base, whatever you want to call it, the side, and you cube it. You take it to the power of 3, okay? So if this has, if that's your side, then you just have to put it to the power of 3 and you'll get your volume. So they're telling us that the side length is 5x, okay, let me try that again, 5x, y, z. Just to let you know, I do write my z's with a little line through it so you know it's not a 2, okay? And we're going to set it up. I'm going to replace s with this. At this point, if you're watching the video, go ahead and pause and see if you can get it. Those of you out here in Zoom land with me, go ahead and put it in the chat once you have simplified this. I want to see your best attempt at that, okay? Let me go ahead and pause this. All right, ladies and gentlemen, so if we're applying the rule, what we wanted to go ahead and do is make sure that you have your little ninja exponent right here, right? And you're basically distributing and multiplying it times each and every exponent, okay? Including the coefficient. Because if I was to have written this out, it would look like this, 5xyz times 5xyz times 5xyz. So a real common mistake was people didn't know what to do with the coefficient. Well, you have the coefficient 3 times being multiplied, right? So that's essentially the same as saying 5 to the power of 1 times 3, and x to the power of 1 times 3, y to the power of 1 times 3, and z to the power of 1 times 3. And you end up with this 5 to the third, x to the third, y to the third, z to the third, okay? And then you're going to go ahead and put that in your calculator, 5 to the third power. Whoops, that's not to the third power. That is to the third power. You get 125. So 125 x to the third, y to the third, and z to the third. So if you made a slightly different, like a real common coefficient was 15. So that might have been the mistake there, is although we're adding the coefficients, we are simply multiplying the 5s, right? 5 times 5 times 5. That's how we got 125. So do you see your mistake if you made it? Okay, hopefully. All right, let's keep trying. So we're going to get into really like more complex type of things that we need to simplify, and there's some general rules, okay? First rule is, and I have it here. Aha, there we go. Number one, each variable base appears exactly once. Okay, so let me give you for example. For example, if I had x to the power of 2 times x to the power of 5, I've got the same base more than once. That is not simplified. This would be simplified. Yes. So I'm going to put a little no on that one. That's not simplified. Okay. All right, let's look at the next rule. No power of a power. To me, this is kind of easy to remember because usually anytime we have parentheses in something, it's not simplified, right? We always want to get rid of parentheses. So no power of powers. And so if I have something like this, x to the power of 2 with a 5 right next to it, that's not simplified, but this is, right? So I'm going to put a little no on that one. Okay. Number 3, all fractions are in the simplest form. Okay. And so, for example, if I had 1 over 4 to the power of 2, that is not simplified, but I could always put it in here like so. 1 over 2, 1 over 4 rather, go out, put in my little exponent of 2, and ladies and gentlemen, we have 1 over 16. That is nice and simplified. Any questions on that? These are some general rules, okay, when you're simplifying monomial expressions. So let's look at this hairy beast right here, right? Okay. The thing I think we want to focus on first is kind of getting rid of those outer ones, right? So let me just tackle this right here. And what I want to do is I want to let's see if I can highlight it. I want to get rid of this, and I want to get rid of this right here, okay? That's what I want to get rid of. So everything inside of there is going to happen 2 times, right? And actually, you know what? Instead of doing this, who can propose instead of me writing it all out, there I am with the tendency of writing it all out. What could I do that would be so much faster? Just do what? No, because the calculator, and that's a good point. I get a lot of people like, do. The calculator will give you an answer, but it's the wrong one. And the reason being is that it assumed that it knows what the value of G is, right? So let's say I put in 8 and then I find G on here somewhere. Where is it? Oh, there in green, alpha G. And people are like, look, I got the answer, miss. No, you didn't. Because the calculator assumes that it knows what G is. And that would be the correct answer as long as G was actually 0. We don't know what G is. Thank you, Miss Sonia. Basically, guys, y'all can multiply all of this stuff as long as you've got this and this, right? Let's just multiply these 2. Yes, because that's the only exponent in there. So we can say 2 times 2. This whole thing is actually equivalent to 8G to the 3rd power, H to the 4th. That's all that stuff, right? And then we got 2 times 2, 4. Are you with me? And I'm going to make a little note here that we didn't add it. We were actually multiplying 2 times 2. Yes? Okay. So if I want to do this one, let's see. So now I can write this one right here. 2GH to the 5th times 4. Bless you. Okay. Now that we have this, that's when we have just one exponent. Here we have lots of things. I'm going to go ahead. I'm going to put the ninja in. I got a ninja 1 right here on the coefficient. A lot of people forget that one. I got another one right here, and I got another one right there. Those are supposed to be 1s, guys. Okay. So I'm going to go ahead and write it out. That's 8 to the power of 1, g to the power of 3, h to the power of 4. Okay, over here, I have 2 to the power of 1, g to the power of 1, h to the power of 5. I'm going to go ahead and I'm going to multiply each and every one. In this case, it's going to be times 4. Most common mistake, people forget to multiply times the coefficient of the, like times the exponent of the coefficient. Here we're multiplying everything by 4 again. And if I'm going too fast, just let me know that I am going to be multiplying. And I end up with 8 to the 4th power, g to the 12th, h to the 16th, times 2 to the 4th, g to the 4th, and h to the 20th. And now it looks like the problems that we were doing yesterday, right? Let's bring all the coefficients up front. 8 to the 4th times 2 to the 4th, g to the 12th times g to the 4th, h to the 16th times h to the 20th. Chloe, you need to take notes. Okay. So basically, can I add up the exponents for the 8 and the 2? Yay or nay? Okay. No, common mistake, right? Your bases have to be exactly the same. So I can do it with the h's. I can say 16 plus 20 and I get 36. I can say 12 plus 4 and I get 16. But I can't do that with this, okay? So my recommendation is you could do it by hand, or you could just plug it in. 8 to the 4th power times 2 to the power of 4, and you get 65,536, and this is your answer. Questions? All right. So on that one, that is basically as far as we're going to take it with our 2 properties that deal with multiplication properties of exponents. And I hope you enjoyed it. Let me